In this video, let's review some right triangle trigonometry. Okay, so we start with a right triangle, an angle theta, which is one of our acute angles, and then let's start with labeling the sides. So the hypotenuse is always going to be across the right angle. Depending which acute angle your theta is in, across theta will be your opposite leg, and next to theta is your adjacent leg. Here are your trig ratios. Sine of the angle is equal to the ratio of the opposite over hypotenuse. Its reciprocal cosecant is hypotenuse over opposite, or 1 over sine. Now I can remember that sine and cosecant go together because an S and a C go together, just like Samuel Clemens. Works the same for cosine. Cosine is the ratio of the adjacent side over hypotenuse. Its reciprocal is secant. Again, you have a C and an S. So secant is hypotenuse over adjacent, or 1 over cosine. And then the last trig ratio is tangent. Tangent of theta is the opposite side divided by adjacent, and its reciprocal cotangent. Well, in this case, we don't have an S and a C, but tangent and cotangent just sound alike, so those are the reciprocals. And cotangent's also equal to 1 over tangent theta. So in geometry, you are probably first acquainted with the trig functions that represent ratios of legs of right triangles. We now revisit this topic, with the only difference being that we will place these right triangles inside a circle and view them as reference triangles. For the point xy on a circle of a radius r at an angle of theta, we can define the 6 important functions as the ratios of the sides of the corresponding triangles. So sine of theta is equal to the opposite over hypotenuse, or y over r. Reciprocate it and you have cosecant of that angle. Cosine adjacent over r, secant is r over x, and tangent opposite over adjacent, so y over x, and its reciprocal cotangent x over y. Note that from 1 and 3 above, we can make observations that x is equal to r cosine theta and y is equal to r sine theta. So in these two, numbers 1 and 3, if we were to solve for x and y, you would multiply both sides by the r, and that's how we get this. Now, if the reference triangle under consideration is embedded in a unit circle has a radius of 1 unit. If our r value is equal to 1 in both of these equations, well then x just equals cosine theta and y equals sine theta. So our x is just cosine, our y is just sine. Now, if we use our Pythagorean theorem, x squared plus y squared equals 1, and make a substitution for x and y with cosine and sine, then we have our Pythagorean identity. Cosine squared theta plus sine squared theta is equal to 1. And just check out this note. Sine squared theta means sine theta squared, not theta squared. Let's work through an example. It says find sine, cosine, tangent, secant, cosecant, and cotangent of this triangle. All right, and so it's telling you which angle to start at. So we're working with angle A. And the other thing we need to do is go ahead and find our hypotenuse. Hypotenuse is always across the box. It's the longest side on a right triangle. We use Pythagorean theorem, so 5 squared plus 9 squared is equal to c squared. So 25 and 81. And so c is equal to the square root of 106. Now, if you can simplify it, you should, but I don't believe 106 will simplify. So sine of A is the ratio of the opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. I like to write it like this because it reminds me it's that ratio that we're looking for. So across the triangle is the opposite. So across from A is 9. So this would be 9 over root 106. And we can leave it like this, but sometimes it does ask you to rationalize it, and so we'd multiply the top and the bottom by the square root. And the square root in this case would be square root of 106. So then this will simplify to 9 square roots 106, and then essentially you are squaring this square root, so that would just give you 106. By rationalizing, you're removing the square root from the denominator. Okay, so naturally we can find the cosecant of A if we take this very first step and just reciprocate it. So cosecant of A is equal to the square root of 106 over 9. And now that one's done. Let's find cosine. Cosine is the ratio of the adjacent. So in this case, that would be the 5 over the hypotenuse. And if we rationalize it, that would give us 5 roots 106 over 106. Its reciprocal, secant, start at this first step, flip it, and we have secant. And then the last trig ratios we want to find are the tangent and cotangent. So tangent is opposite over adjacent, and so, that would be 9 over 5, and cotangent 5 over 9. And we don't have to worry about rationalizing or anything there. In problem number 6, let's work through Pythagorean theorem in order to solve for b. So 3 squared plus b squared is equal to 14 squared. 9 plus b squared is equal to 196. Subtract 9 and take the square root, and so b is equal to the square root of 187. And I don't believe that cleans up anymore. So we'll just leave it square root of 187. Next, we need to figure out what these angles are. So let's just start with angle A. From A, if I draw an arrow across, my opposite value is 3. The hypotenuse is 14. I'm going to go ahead and use sine. Sine of A is equal to opposite over hypotenuse. So if I want to figure out what A is, I need to undo sine. And I can undo sine by taking the inverse on both sides. Or applying the inverse on both sides. So on the left side and the right side, I'm going to take inverse of sine. That will cancel out the sine and leave me with just A. All right, so if you are finding an angle, we need to undo sine with sine inverse. It's an equation, so you must do it on both sides of the equal sign. So inverse sine cancels with sine, and we're left with A. A is equal to inverse sine of 3 over 14. So let's take that to Desmos. Okay, so I'm going to go ahead and type in sine, and then I want to raise it to the -1. This will be inverse sine. And let's see, that was inverse sine of 3 over 14. Make sure you're in degree mode, so I'll click on my little tool over here. I'm in degrees, and so I've got 12.374 degrees, or just 12.37 degrees is probably fine. All right, so this was my A, 12.37 degrees. And now A and B are complementary angles. They are going to add to 90, since I already have a 90 degree here. And so I can just subtract 90 minus 12.37, and that's going to give my angle B 77.63 degrees. In problem number 4, if all you're given is cosine, tangent, when sine of A is root 12 over 4, please draw a triangle. Okay, so I'm working from angle A, and so I've already kind of set this up a little bit. Here's my angle A and my right triangle, and whenever you've got trig, you know we're working with a right triangle. So angle A is either going to be down here or up here. It's got to be one of the acute angles. And then if you just label, go across, that's the opposite. Hypotenuse is always across the box. It's the longest side, and then the adjacent's the third side. So I've been given that the sine of A is square root 12 over 4. Now, sometimes you may need to simplify this. So I'm just going to do a quick simplification of square root of 12. 2 goes in 6 times, and then 2 goes in 3 times. When you have a pair, that comes out. So square root of 12 is equivalent to 2 roots 3. Sometimes I'll use the square root of 12, sometimes I'll use 2 root 3. And I'll show you what I'm talking about. All right, so let's see. I'm going to go ahead and identify as 2 roots 3 is my opposite. My hypotenuse is 4. And I need to find the adjacent. So I'm going to go ahead and call the adjacent side little b. So if I use Pythagorean theorem to solve for little b, I've got a squared, and I'm going to go ahead and use the square root of 12 because I'm squaring a square root when you're, well, in this case, for Pythagorean theorem. So this is going to be my a squared plus b squared is equal to c squared. So square cancels a square root. I'm left with just 12 plus b squared is equal to 16. If I subtract 12 both sides, that'll give me 4, and I take the square root. B is equal to 2. Now let's find cosine. Cosine of A is equal to adjacent over hypotenuse, so that's 2 over 4, which is 1 over 2. Its reciprocal, secant, is just going to give you 2 over 1, or just 2. Let's see, tangent of A, that's opposite over adjacent, so 2 roots 3 over 2, and so that just gives you roots 3. And its reciprocal, cotangent, is equal to 1 over root 3, and if I rationalize it, that just gives me root 3 over 3. And then the last thing I need to do is find cosecant. Cosecant of A is the reciprocal of this guy here. So 4 over 2 roots 3, which is 2 over root 3, and if I rationalize it, that'll give me 2 roots 3 over 3. These are equivalent. So it just depends on what your answer looks like. You may need to rationalize it. You may need to simplify the radical. In number 14, we've got a word problem. A 70-foot statue is located in the distance. So here's my statue. I don't know. That doesn't look good. Let's try this again. Here's my statue. I don't know what it is. But we know that it's 70 feet tall. And it's in the distance from a window in a building. Here's my building. Here's my window. And here's my person. The person determines the angle of elevation to the top of the monument is 13 degrees. So we're looking up at the top. This angle, an angle of elevation is always from the horizontal, is 13 degrees. Here's my right triangle. If we're in the right triangle trig unit, we know we're going to have a right triangle in there. The angle of depression to the bottom of the tower is 8 degrees. And this is not drawn to scale, but approximately, this is my 8-degree angle here. That looks like 80, but it's really an 8 degrees. How far is the person from the monument? So I'm looking for the distance, the horizontal distance that that person is from the monument. So the biggest challenge in these problems is drawing your picture. You've got to draw an accurate picture. Make sure it makes sense. An angle of elevation is always an angle that looks up. An angle of depression is always an angle that looks down. All right, so let's go ahead and make one more marking on this. If I know that the vertical height is 70 feet, I'm going to go ahead and call this height on the triangle x. That means the top triangle will be 70 minus x. And make sure that makes sense. If the whole thing is 70, the bottom triangle has a vertical height of x. That means whatever left, 70 minus x, will apply to the top triangle. All right, so now we can start figuring out which trig ratio we want to use. Well, if I go across these angles, I've got the opposite side. And the D represents the adjacent side for both of these angles. And so if I want to use a trig ratio that relates the opposite and adjacent sides, I need to be using tangent. Let's set up a tangent equation for both of these triangles. So we'll take the top triangle. Tangent of the angle is equal to opposite over adjacent. That's a D. And tangent of 8, tangent of the bottom triangle's angle, is equal to opposite over adjacent, also D. Both of these equations have a D in them. If I solve both of these equations for D, this would give me D is equal to, well, 70 minus x divided by tangent 13. Oops. Sorry about that. I meant to hit my arrow. All right, so I've multiplied both sides by D. That gets the D out of the denominator. But I want to isolate D, so I need to divide both sides by this tangent 13. And that's how I end up with this equation here. I'll do the same thing for that second equation. D equals, all right, so I'm going to multiply both sides by D. That gets it out of the denominator. But then I need to divide by tangent 8 to isolate the D. So this is going to give me x over tangent 8. Now, if both of these equations are equal to D, I can set them equal to each other. So 70 minus x over tangent 13 is equal to x over tangent 8. All right, now I have a proportion. Let's go ahead and multiply and solve for our x. Okay, if I multiply like that, that is going to give me x times tangent 13 is equal to tangent 8 times 70 minus x. X times tangent 13 on the left, tangent 8 times 70 minus x on the right. Now I do need to distribute this tangent 8 to both of these terms in the parentheses. So I have x times tangent 13 is equal to tangent 8 times 70, and you know what I'm going to do is I'm going to move that 70 to the front, minus x times tangent 8. Let's get the x terms together on one side. So I'm going to go ahead and add this term with the x to the left, and I'll have x times tangent 13 plus x times tangent 8 equals 70 tangent 8. Now, both of these terms have a common factor, which is x. So that's my GCF I will factor out. So x on the outside, and then tangent 13 plus tangent 8 is equal to 70 tangent 8. We have one last step to isolate the x, and that would be to divide both sides by tangent 13 plus tangent 8. All right, so we finally got the x by itself. We just need to type this into our Desmos calculator and see what it equals. So all of this gets put into the calculator. And that's what I've got in this first line here. 70 tangent 8 divided by tangent 13 plus tangent 8. In the calculator, if you're in degrees, then you'll get 26.4879 as your answer. So let's just round it to 26.49. All right, so that's x. Now that doesn't answer my question, but it gets me a little bit closer to where I need to go. So if I go ahead and identify this guy as 26.49. Now if I want to solve for D, I just need to use this bottom triangle. Tangent of 8 is equal to opposite over adjacent. Let's get the D by itself. Let's multiply both sides by the D and divide by tangent 8. And D is equal to 26.49 divided by tangent 8. If I put that into my calculator, you know what, I'm going to go ahead and use a few more decimal places just so I'm not prematurely too rounding. So 26.4879 divided by tangent 8, and again, you got to type in the word tangent, open parentheses, 8, 188.471 feet. That's how far the building is from the monument. And make sure you're putting your units. All right, one last example. It says find x. So let's take a look at this triangle and see if we can fill in any of the missing parts. For example, if I have a right triangle, or if I just have a triangle, I know that the sum of the three angles is 180. And in this case, it's a right triangle, so I know the two acute angles are complementary. So the complement of 74 is 16, because 16 plus 74 add to 90. All right, so I can find the supplement of 74, 180 minus 74, and that's 106. Now I can find this other angle at the top of the this obtuse triangle. If I have two angles, 106 and 42, I can add them together, subtract from 180. So let's see, 106 and 42, that's 148. So this guy must be 32 degrees. Okay, so I filled in all my angles. That's a start. Next thing, let's go ahead and see what I recognize is I've got the hypotenuse on this right triangle here. So I can figure out, well, next to the 16, this is my adjacent. This is my hypotenuse on the right triangle, and that hypotenuse happens to be 130. So I can set up this equation. Cosine of 16 is equal to adjacent, and let's go ahead and just call this guy y. He's a vertical height, and so I'll just call him y. Adjacent over hypotenuse. Here's my first step. Okay, so if I want to isolate the y, I would multiply both sides by 130. So 130 cosine of 16 is equal to y. That's going to give me this vertical height on the left. So 130 cosine of 16. Okay, 124.964. So this guy is 124.964. All right, that is the vertical height on that triangle. And I'm just going to write it here. Okay, so next I want to go ahead, and since I have to the two sides of this right triangle, I can use Pythagorean theorem to find this guy. All right, so let's call this guy, I don't know, this side, let's call him A. So A squared plus 124.964 squared is equal to C squared. A squared plus B squared is equal to C squared. All right, so let's work this out. I'm going to grab my Inspire calculator just because it's a little bit faster. 130 squared minus 124.964 squared. And then if I take the square root of that, that gives me 35.8329. So my A, 35.8329. All right. The last piece I need to work on is this side of the big right triangle. So now I'm focusing on this guy I've highlighted in purple. Okay, so the angle at the top, if I add 32 and 16, 32 and 16 makes 48. This big angle here is 48. I can find the side opposite, which is this whole big side, and I'll just call him B, because I also have the adjacent side. So I can do opposite and adjacent to solve for B. So I'll go ahead and use cosine. So, I'm sorry, opposite and adjacent. Just kidding, I'm using tangent. Tangent of 48 is now opposite over adjacent. All right, let me just make sure everybody followed me there. I added these two acute angles, got 48. So the angle at this big triangle at the top is 48. This is the side opposite of this angle, and I have the adjacent. I'm not worrying about the hypotenuse, so I'm just working with opposite and adjacent, and that's the ratio of tangent. So it's tangent of the angle, tangent of 48, is equal to the opposite over the adjacent. And I did that because now I'll be able to figure out what B is, and I subtract A to figure out what X is. Okay, so almost done. Let's multiply both sides by 124.964. And that gives me what my B is. So, and again, I'm going to just jump onto my Inspire calculator just because it's a little quicker. 124.964 times tangent of 48. And that gives me 138.787. So B is 138.787. I haven't answered the question because I'm just looking for X. But if I know that this whole thing is 138.787, if I subtract A, I'll figure out what X is. So in my calculator, I'm just going to subtract 35.8329, and I get that X is equal to 102.954. So what I did is I took the 138.787, that was the side opposite of my angle 48, subtract the value that we found for A, 0.8329, in the calculator, that gives me 102.954. That's what my X is.